Hello guys. In the third question in the first homework, page 135, it's an official question, year 2001. Okay, it's the same as the previous questions, but I'll just correct it quickly. Okay, the first, in order to determine the force constant K, which is the spring constant, or it's called the stiffness of a spring of negligible mass, we fix the extremity A dot. Negligible mass, the spring has a negligible mass, not the block itself. Okay, so we fix the extremity A of the spring and connect to the free extremity. This is called the free extremity of the spring. الفري الحرة اللي بالهواء علقنا فيها الماس. A solid S of mass 200 grams. Of course, we want to convert this mass into kilograms. The spring hangs vertically as seen in the figure. Okay. Name the forces acting on S and tell for each of these forces whether it is contact or force acting from distance. They could ask classify the force or the classification. So, of course, you know that the first force is the tension and the second force is the weight. The weight starts from G, which is the center of gravity or center of mass of the block, while the tension starts from B. Okay, so we have the tension and the weight. We write the symbol representation for each force, the vector representation, T vector and W vector. The weight is a force acting from distance, while tension is a contact force. Okay. So the second question, the solid S is in equilibrium. Say gravity equals 10 newtons per kilograms. Give the condition of equilibrium. Okay. I'll just increase the speed of the video. Okay. So the condition of equilibrium is T vector plus W vector equals 0 vector. The second step, we send the weight to the right. T vector equal minus weight vector. Okay. The magnitude relation is T equal W. Part B, determine the magnitude of each of the forces. We can't calculate the tension since we don't have neither of the stiffness nor the elongation. So we calculate the weight from weight equal mass times gravity, which is 200. We divide it by 1000. This is the conversion from grams into kilograms. Okay, and we multiply by the gravity, which is 10. The answer, of course, is about 2 newtons. Part C, represent the forces. We already did represent them on the figure. The third part, the solid S is in equilibrium. The elongation of the spring is 5 centimeters. Calculate the force constant of the spring. Okay, so now we have the elongation, which is the delta L, 5 centimeters. We want to calculate the stiffness constant or the spring constant K. So according to Hooke's law, T equals K times delta L. So we want to calculate K equals T over delta L. We just substitute the tension 2 and the delta L is elongation 5. The answer is 0.4 newtons per centimeters. Okay, to convert into SI unit, which is Newton per meter, so we just multiply by 100. From Newton per centimeter to Newton per meter, we multiply by 100. The answer will be, of course, 40 newtons. Okay. We can also solve this into another method, converting the elongation into SI units from the beginning. 5 centimeters is 0.05 meters. Okay, I'm sorry. We'll get the final answer into SI units. Okay, so 2 over 0.05, which is 40 newtons per meter. Thank you so much.